Okay, I'll be referring to this document, functions. Looks something like this. I already went ahead and put example 1 on the board. I'm not going to write every single thing that it says. I'm just pretty much just going to do the problems and tell you what page we're on. Okay, so example 1A says determine if this is a function. Well, you guys can read the definition of a function. A function involving numbers is a relationship between numbers with an input variable and an output variable, and each value for the input variable has only one output. Okay, so to determine whether this is a function or not, we're going to go ahead and write the input variables and the output variables in order. So I got the lowest input variable I see is -2. The first coordinates are the input variables. So -2, -1, 1, 2, and 5. Okay? We also have the lowest output variable I see is value is 0. And then we have 3. Then 4. Okay, I'll write 4 only once. And then we have 7. Now, -2 is matched with 3. -1 is matched with 0. 1 is matched to 4. 2 is matched to 7. And 5 is matched to 4. Each one of these input variables has only one output. Okay? Only one arrow coming from it. So this is a function. Okay? This is a function. Okay? The domain is a set of inputs. So the domain would be -2, -1, -1, 2, and 5. The range is the outputs. Range. 0, 3, 4, and 7. Okay? Example 2. I'm going to pause this and put example 2 on the board. All right, example 2 is on the board, and we're going to repeat the same process. It's the same questions. A, is it a function, and if so, to identify its domain and range. So the inputs and the outputs. Okay, lowest input I see is -5. I have 0. I'm not repeating the 0, and then there's 7. Okay, the lowest output I see is 1, then 3, then 4, and then 6. All right, -5 is matched with 6. So far this is a function. 0 is mapped to 1, and then 0 is mapped to 3. This is not a function. That right there disqualifies this from being a function. This input has 2 outputs. All right, now 7 is mapped to 4, not that it matters at all. Okay? This is not a function. Well, it's not a function. So since it's not a function, it doesn't have a domain, it doesn't have a range. Okay? So if it's not a function, it doesn't have a domain, it doesn't have a range. That's the reason why I chose the words inputs and outputs. Okay? Because just because it's an input doesn't mean it's a domain. Just because it's output doesn't mean it's a range. Okay? It has to be a function. So here's the difference. All of these inputs had only one arrow going out from them, matching them to an output. Now, this output had two inputs, but that doesn't matter, okay? Outputs can have multiple inputs, but inputs can only have one output, okay? So this disqualifies this from being a function, okay? Okay, I admit this is the first time I'm doing this with a projector. So you'll have to please bear with me as I try to make this work. Okay, so we're on page 2, and here's example 3. Okay, example 3. The graph of the relation is below. Answer the questions. So there's something called the vertical line test. You can read about at the top of page 3. It says that in graphs, the input variable is the horizontal axis, it's normally x. The output variable is on the vertical axis, it's normally y. Okay, I'm reading something that's off screen. If the graph is a function, a vertical line should cross it only once everywhere. That would mean that every x has only one matching y. If it crosses more than once, the graph is not a function. So I will actually be stacking up all 3 of these markers to determine if this is a function. Okay? And as I run it across, this vertical line crosses only once everywhere the function exists. Okay? Vertical line. Okay? If you want to put an imaginary vertical line between the markers, and it crosses once everywhere. Okay? This is a function. The next appropriate question would be its domain and range. The domain goes from, let's see if I can get this thing closer to it, even though you should have your own printout. Okay? This is -1, this is -2. So this point is -2. 1, 2, 3, 4. -2, 4. And this is 2, 3, 4, 5. This is 5, 6. Okay? So, the domain goes from x equals -2 to x equals 5. So that's -2 is less than or equal to x, which is less than or equal to, I'm going to rewrite that, which is less than or equal to 5. Okay? Or in interval notation, those are closed dots. So -2 to 5. Okay? And then the other part asks about the range. The range is the set of vertical coordinates that exist. So the low point here is 0, 0. Okay? So the range goes from 0, the y coordinates go from 0 up to 6. That's the range. 0 is less than or equal to y, which is less than or equal to 6. Okay? The range, the set of vertical coordinates that are available. 0 is the low y value, 6 is the high y value. So, 0 to 6, okay, with brackets. Okay, I'll put the next one on the board. Example 4. Now, if you'll notice, these have arrows. Okay, that means they go on forever in those directions. Okay? Now, if we run our vertical line across, it crosses once everywhere. Okay? So, this is also a function. Now the domain. These arrows indicate that it will go on forever in both directions. Okay? Go forever in both directions. So as a consequence, the domain goes forever that way, it goes forever this way. So the domain is all real numbers. Okay, all real numbers. In interval notation, that's described as negative infinity to infinity. The range, well, that's a different story because that's the low point. Okay? That's the lowest y value. There's no limit to how high the y's can go. Okay? So it's y is greater than or equal to 0. Okay? Because that's the lowest y, but the y's can be forever up. Okay? In interval notation, that would be described as 0 to infinity. Okay? Because again, the domain, as far as the x's are concerned, it goes forever this way. Okay? But as far as the y coordinates go, there's a lower limit, but there's no upper limit. Okay? The y's can go up forever. Right, I'm going to switch sheets again, so I'll pause at this point. Okay, the question here is, so we're on page 4. Example 5 asks if this is a function, and if so, what is its domain range? Well, so far so good. It crosses only once. Crosses only once, crosses only once, now it crosses twice. Okay? Crosses twice, as you can see. So this is not a function. This also, so it would, this is a function so far, and then it stops being a function when it has 2 crossing points. Okay? This would be fine, this would be fine, and again, this would not be fine. That's 2 crossings as well. Okay? So this is not a function. Since it's not a function, it doesn't have a domain or range. Now for example 6, I provided another graph, and it says, what is the domain range of the function below? Well, I already told you that this is a function. Okay? That information was provided. That's a function. Okay? So that's not a yes or no question about whether it's a function or not. I told you it's a function. The question asks, what's the domain and what's the range? Well, these arrows indicate that it continues forever in this general direction. Ditto down here. Okay? So the domain is all real numbers. It extends forever. Or in interval notation, negative infinity to infinity. So that's where that comes from. The range, it can go up forever, it can go down forever. Okay? So it goes on down here forever, it goes up forever. So the range is also all real numbers, described as negative infinity to infinity. Okay? So I'm going to pause now and change pages. 5. And with example when we have f of x equals 5 minus 4x, find f of negative 11. The steps on top of the page say plug a value in parentheses in for the variable, simplify, and calculate. So f of negative 11 would be 5 minus 4 times negative 11. Okay? I'd multiply that first, so that would be 5 plus 44, which is 49. Okay? This one, f of 3 would be 2 times 3 squared plus 5 times 3 minus 17. Well, 3 squared is 9. 9 times 2 is 18 plus 15 minus 17. 33 minus 17 is 16. All right. Here I have f of x is 4.1 to the x minus third. F of 5 would be 4.1 to the 5 minus third. You will want to simplify the exponent first, and that would give you 16.81. Because 4.1 squared is 16.81. Okay? I'm going to clear the board off, and I'm going to put up the next two examples. Here's what we do for example 4. G of negative 6 would equal the square root of 3 times negative 6 plus 34. That's negative 18 plus 34. Okay, add these two up, you get the square root of 16. The square root of 16 is 4. Okay, now for this, I'm going to do the top and bottom separately. Okay, and then I'll combine the results later. Actually, let me go ahead and finish the problem. Find f of 4. Okay, so I have f of 4 equals the fifth root of 4 plus 1020 over 3 times 4 minus 13. Okay, I'll do the top and bottom separately. The top is going to be the fifth root of 1024, which is equivalent to 1024 to the 1/5 power. Okay? If you take your calculator, and I will, even though I know the answer, I'm going to go through the motions. It'll be 1024. I'll hit my generic exponent button. They vary from calculator to calculator. I will open a parenthesis, 1 divided by 5. I will close the parenthesis, hit enter or equal. I got 4. Okay? But that's 12. 12 minus 13 is negative 1. So, combining the results, I have 4 over negative 1. 4 divided by negative 1 is negative 4. Okay? So that's what you should do when you got fractions, with any sort of complication to them. Do the top separately, do the bottom separately, and then combine the results and simplify. All right, I'm going to pause here and change and go back to the graph. 6. I went ahead and provided the function, and I provided its graph. Okay? So it says to find f of negative 1. Okay, f of negative 1, if I was going to do it by graph, so AA is algebraically, okay? So that would be negative 1 cubed minus 3 times negative 1 plus 4. Okay, that's going to be negative 1. Negative 3 times negative 1 is positive 3, plus 4, I get 2, plus 4 is 6. Okay, now if I was to do this by graph, here's the graph. Okay, by graph. So here is x equals negative 1 on the graph. I will either go up or down to meet the appropriate coordinate on the graph. So 1, 2, 3, 4, 5. Hold on a second. Okay, so here goes. So I got x equals negative 1. I will go up or down to meet the curve or the line or whatever. So x equals negative 1, and then I will go straight up, and the y coordinate is 6. Okay, so at x equals negative 1, y is 6. Okay, so f of negative 1 is 6. All right, I'm going to do the same thing on page 7. Okay. I'm keeping the same function. All right, this time I'm going to switch the order around. Find f of -2 by graph. So I'll do B first. Okay? B. Find f of -2 by graph. Then I'll do A. Okay, so here's where x equals -2 is right here. Okay? X equals -2. I'm going to go up and I'll meet the graph and it looks like the y coordinate is 2. Okay? X equals -2, y equals 2. Okay? So f of -2 is 2. Okay? I'll follow these up with more examples. A, we'll confirm it. F of -2 is -2 cubed minus 3 times -2 plus 4. Let me move this down first to avoid confusion. A, f of -2 by graph would be -2 cubed minus 3 times -2 plus 4. All right, so -2 cubed is -2 times -2 times -2, which is -8, plus, this minus times the minus is a plus, and then plus 4. -2 plus 4 is 2. Okay? More. Okay? Let's talk about more. Okay? Which is not on your graph. Well, let's talk about, say, f of 0. If I go to x equals 0 on the graph and go up to meet it, it's 4. Okay? Let's say I want f of 1. Well, I go to where x equals 1 on the graph, and I go up to meet it at 2. Okay? So that's the basic idea. Okay? So now we're on page 8. Okay? And as you can see, there is no rule for this function. Okay, I didn't provide one. It's not available. There is no f of x equals. Okay, it looks like I need to move this thing around some. Okay? There is no y equals rule here. This is all we have. We have just this graph and only this graph. Okay, so here's f of x. There's no rule that you can plug numbers into. So to find f of 2, now let me go ahead and put this down there. Okay, f of 2. We're going to go to where x equals 2 on the graph. I'm going to move up or down to find the matching y. So at x equals 2, y equals 1. More. Okay, I'm going to ask for more examples. So we'll talk about, say, f of -1, f of -2, f of 0, and f of 4. So f of -1, I'll go to x equals -1 on the number line, and I will go up and meet a y coordinate of 1. At x equals -2, I go up and I meet a y coordinate of 4. When x equals 0, the y coordinate is also 0. And at f of 4, I will go to where x equals 1, 2, 3, and 4. And when I get there, it's the y coordinate is 2. Okay? All right, we are on page 9. Here we have f of x graphed. And the question asks, what f of 5 is. Well, f of 5 is, I go to where x equals 1, 2, 3, 4, 5. Okay, so here's where x equals 5. I'm going to go down to meet the graph, and the y-coordinate is negative 1. Okay, I'll do that again. I'll go to where x equals 5, 1, 2, 3, 4, 5, and I will either go up or down to meet the curve. Looks like it's down in this case, and the matching y is negative 1. The next question asks the domain. Well, these lines go forever both ways. Okay? So horizontally, it's all real numbers. In interval notation, that's negative infinity to infinity. Now the range is not so simple. The range, it goes down forever. These arrows mean this is going to go down forever. But there's an upper limit to the y, and that is 6. Okay? So the upper limit is 6, but there's no limit to how low they can go. So y is less than or equal to 6. That's the upper limit, but there's no lower limit. Okay, interval notation, that would be the lower limit would be negative infinity, but the upper limit would be 6. Okay, that's the highest y-coordinate we can have. The y-intercept, that's where it crosses the y-intercept. It crosses at 0, 5. The x-intercepts are where it crosses the x-intercept, or the x-axis. So that would be negative 2 is the x-coordinate. 0 is the y-coordinate. And the other one is this one, 4, 0. All right. I'll pause it. All right, so here I am I'm trying to sketch this graph. Actually, give me a moment. I went ahead and turned off the document camera. I don't need it anymore. Okay, I'm not going to need it anymore. I'm not going to need the projector anymore. And I'm going to zoom this thing back so I can actually see everything. And you can actually see everything. It's all in on the board. Okay. Now what I propose to do is I propose to sketch the graph of this function. You have a copy on your paper, your printout. Now, this is the starting point. Here's the function we have to sketch, and here's the graph the grid that we have available. And I'm going to make it very simple for you folks. If it doesn't come anywhere close to fitting, don't bother plotting it. Okay? So in the absence of any other method available to graph these, we're just going to start at the left and work our way across to the right. So at x equals negative 4, this takes the role of y. So y would equal negative 4 cubed minus 3 times negative 4 plus 4. All right? I start here at x equals negative 4. So this is negative 64. That's plus 12. That's plus 4. All right? So negative 64 plus 12 plus 4 is negative 48. So the first point would be negative 4, negative 48, which doesn't come anywhere close to fitting, because that would be negative 4, and that would be way down here below. Okay, so it doesn't come anywhere close to fitting, so I won't even bother to plot it. X equals negative 3. So we did negative 4, now we'll do negative 3. Y equals negative 3 cubed minus 3 times negative 3 plus 4. So that's negative 27 plus 9 plus 4. So negative 27 plus 9 plus 4, negative 14, which doesn't come anywhere close to fitting. That'd be negative 3, negative 14. Okay? Doesn't come anywhere close to fitting, so we won't worry about it. Negative 4 is done, now negative 3 is done. Now we'll do negative 2. So everywhere where I see an X, I stick in a negative 2. That's negative 8. That's 6. That's plus 4. So negative 8 plus 6 plus 4 is 2. So that's negative 2, 2. Okay, if you want, you can plot it at this time. Negative 2, 2. All right, so negative 4, negative 3, negative 2. Now we'll do X equals negative 1. Y will equal negative 1 cubed minus 3 times negative 1 plus 4. Okay? So that's got to be negative 1 plus 3 plus 4. That's going to be 6. So negative 1, 6 is the point. Negative 1, 6, right there. All right? So now we'll do X equals, we've done negative 4, negative 3, negative 2, negative 1. Now we will do 6. Sorry, we will do 0. Okay? So X equals 0, Y equals 0 cubed minus 3 times 0 plus 4. Okay? I understand there's a bit of a glare there, so I think I'll move this down again. Okay, so we did negative 4, negative 3, negative 2, negative 1. Now we'll do X equals 0. X equals 0. Y equals Y equals 0 cubed minus 3 times 0 plus 4. Okay, so that's 0 minus 0 plus 4 is 4. So we have 0, 4. Okay, so we did negative 4, negative 3, negative 2, negative 1, 0. Now we will do 1. X equals 1. Y equals 1 cubed minus 3 times 1 plus 4. Okay? So that's going to be 1 minus 3 plus 4. That's 2. So 1, 2. All right. Now we'll do X equals 2. Y equals 2 cubed minus 3 times 2 plus 4. Okay? So that's 8 minus 6 plus 4. 2 plus 4 is 6. So 2, 6. All right. X equals 3. Y equals 3 cubed minus 3 times 3 plus 4. 27 minus 9 plus 4. I bet it doesn't even fit. 27 minus 9 plus 4, 22. So 322. Doesn't come anywhere close to fitting. 322 would be way up here. And then finally we'll do X equals 4. Y equals 4 cubed minus 3 times 4, or minus 3 times 4, and then plus 4. That's 64 minus 12 plus 4 56. So that'd be 456, which doesn't come anywhere close to fitting in the grid. So we're going to draw a curve that fits this general, that hits all these points. So we didn't have anything for these values. This is the first one we had, negative 2, 2, but all the other ones previously were far lower. Okay? And then, let's try and make it look curve-like. Okay? Actually, I'm going to start this over. Okay? I'm going to play a game of connect the dots with the dots we have. So up, back down, here, and then back up. Now, what happens here is that before negative 2, it was lower. So we're going to show an arrow that drops. Okay? And then for after x equals 2, we were going up higher. So our arrow should show us going up higher. And there we go. Okay? You don't need to overthink these. These are just hand-drawn sketches. All right? So I'm going to clean this board. I'm going to clean this off and do the next page. Okay, this is called a piecewise function. Okay, what we're going to be doing here is it's a function which follows different rules depending on where we're at. This is one piece. If x is less than 3, we'll follow that rule. When x is 3 or more, we'll follow that rule. So the boundary is x equals 3. So I'm going to go ahead and put a dotted line. This is in standard, but it's what I usually show students to do. The boundary point is here at x equals 3. Okay? So this is piece number 1. This is piece number 2. Okay? Now, I generally start with the piece that's farthest to the right when I'm showing students how to do this. So the farthest to the right is piece number 2. Okay, and the rule for piece number 2 is that y equals, so this is piece number 2 right here. Okay, the rule is that y equals the square root of x plus 1. Okay, and that is when x is greater than or equal to 3. Okay, so there will be an endpoint, and that's going to be a closed dot because of the or equal to. If it was a strict inequality sign, it'd be an open dot. You'll see that next. Okay, so at x equals 3, endpoint x equals 3. Y equals the square root of 3 plus 1, okay, which is the square root of 4, so y is 2. So we have 3, 2. Other points. That's the end point. Here's the other points. Other points such that x is greater than or equal to 3. Well, we already did 3, so how about x equals 4? We'll do the next integer value. Y equals the square root of 4 plus 1. Okay? Which gives me the square root of 5. So it's not approximately equal to. It is equal to. Okay? And the square root of 5 is approximately 2.236. You can round as approximate as you want, since there are no rounding instructions. Okay, so there's another point. Next we'll do 5. So y equals the square root of 5 plus 1, which is the square root of 6, which is approximately 2.45. So that's going to give me 5, 2.45. We can plot we can go ahead and plot these if we want. I'll say I'm going to hold off until we got this piece done. Then we have x equals 6. Y equals the square root of 6 plus 1, which is the square root of 7. Square root of 7 is approximately 2.646. So we have 2.646. All right, so let's go ahead and plot these things. We determined that this is going to be this endpoint will be a closed dot, so that's 3, 2, because of the or equal to. We also have 4 and about 2 1/4. That's almost 2 1/4. Okay, that's almost 2 1/2. So 5, a little bit under 2 1/2. And then 6, and then 2.646 something. So almost 2/3. And it's a radical function, so it's going to have a curved shape to it. All right. So we also need to do piece number 1. Okay. That is going. So if this piece number 2 goes this way, any other piece would have to go this way. Okay. So piece number 1. That follows the rule. Y equals the absolute value of x plus 2. And the rule for piece number 1 is x has to be less than 3. It's not or equal to, so it's going to be an open dot. It's not or equal to. And the endpoint for this is going to be x equals 3. Of course, that's got to be an open dot, so actually, well, that's fine. It's got to be an open dot when it's plotted. Y equals the absolute value of 3 plus 2, which is the absolute value of 5, which is just 5. So it's 3, 5. I'll go ahead and plot it with an open dot. 3, 5. Okay? Next up, we need other points with the restriction that x has to be less than 3. So 2, 1, 0, and so on. So x equals 2, y equals the absolute value of 2 plus 2, which is the absolute value of 4, which is 4. So 2, 4. We'll go ahead and plot these. These are going to be with closed dots. Okay? Only endpoints can be open dots. Only endpoints. Okay? And that's only under certain circumstances. Okay? And that circumstance is if it's an endpoint and there's no or equal to. Everything else is going to get a closed dot. All right, so we did 2. Now we'll do 1. Y equals the absolute value of 1 plus 2, which is the absolute value of 3, which is just 3. So 1, 3. Okay? 1, 3, 2, 4. All right. Then we did 2, we did 1, now we'll do 0. Y equals the absolute value of 0 plus 2, which is the absolute value of 2, which is just 2. So 0, 2. Okay? Next up, we did 2, 1, 0. Now we'll do x equals negative 1. Y equals the absolute value of negative 1 plus 2, which is the absolute value of 1, which is just 1. So negative 1, 1. Okay? And then we'll do negative 2. y equals the absolute value of negative 2 plus 2, which is the absolute value of 0, which is 0. So negative 2, 0. All right? Next, negative 3. Y equals the absolute value of negative 3 plus 2, absolute value of negative 1, which is 1. So, negative 3, 1. Negative 3, 1. Okay? And finally, x equals negative 4. Y equals the absolute value of negative 4 plus 2. Absolute value of negative 2, which is 2. So 4, 2. Or negative 4, 2. All right. And absolute value, most absolute value equations are functions are going to be V-shaped. All right. All right. As I said, but normally the dotted line isn't going to be there. So I'm going to go ahead and erase this. And usually the graphs of piecewise functions are going to look something like that. All right, so up the next page. Okay, now I'm going to talk about the domains of functions, okay, algebraic functions, ones where you are given an algebraic expression. So, the two basic domain restrictions are denominators cannot equal 0. Reason being, domain is what you can put what real numbers you can put into a function and get real values back. Okay, so real values in, real values back. Division by 0 doesn't exist, so we have to avoid denominators equaling 0. Also, square root radicands must be positive or 0. Square roots of negative numbers are non-real, so the radicand for a square root function must be greater than or equal to 0. Okay, we're going to see both of these in action on this screen. So when you are calculating a function value, you consider only when you are calculating a function value, you include everything. But when you're doing the domain, you include only what's relevant to the question of the domain. So for this one, f of x equals x plus 5 over x minus 13. I'm not asked for a function value. I'm not asking for a function value. I just want the domain. And that it has a denominator. I have to avoid the denominator equaling 0. Okay, so I will add 13 to both sides. And x does not equal 13. So that's the domain in traditional notation. Okay? In interval notation, we would have to describe everything before 13 and everything after 13. So negative infinity to 13 non-inclusive describes what's before 13, and then 13 non-inclusive to infinity includes what's after 13. Okay? Because interval notation has to describe this situation. Everything before 13 is included, everything after 13 is included, but 13 marks a whole. So this describes everything before 13 and everything after 13. Okay? But excludes 13. Okay, f of negative 5. Here I'm finding a function value. So I include everything. I replace x with negative 5. And I'm not going to break this up into top and bottom because it's just an addition and a subtraction. So that's 0, and that's negative 18. And 0 divided by any non-zero value is 0. Okay? Numerators can be 0. Denominators cannot be 0. Okay? All right, f of 14. Do. This is going to be 14 plus 14 plus 5 over 14 minus 13. So that's 19 over 1, which is just 19. Okay? But f of 13. Now remember, folks, 13 is excluded from the domain. So I'm going to show you what would happen. Okay, what excluded from the domain means in this context. So that would be 13 plus 5 over 13 minus 13. And that'd be 18 over 0, which does not exist. Okay? The 13 was excluded from the domain, and when I tried 13, I didn't get anything. Okay? I didn't get a real number back. So that explains why 13 is excluded from the domain. Now, this is a square root function. The square root radicand must be greater than or equal to 0. So do. The radicand is x minus 15. It must be greater than or equal to 0. So I will add 15 to both sides. And x is greater than or equal to 15. That is the domain in traditional notation. Interval notation, it's 15 inclusive to infinity. That's interval notation. Okay, so here we have the domain of, and the reason is because square roots of negative numbers are non-real, so I have to have a square root of 0 or something greater. Now for a cube root, that doesn't apply for cube roots. Cube roots, different ball game. So answer, domain. It's all real numbers. Because that's a cube root. Okay? So in interval notation, all real numbers is described as negative infinity to infinity. All right, and I'm going to pause here. All right. So now I'm going to find the domain of f of x equals x minus 7 over x squared minus 9x minus 190. So this is f of x equals x minus 7 over x minus 19 times x plus 10. Okay, so that means that x minus 19, because the denominator cannot equal 0, times x plus 10 cannot equal 0. So x minus 19 cannot equal 0. X plus 10 cannot equal 0. Add 19. X cannot equal 19. Subtract 10, subtract 10. X cannot equal negative 10. So I'll show you what this looks like graphically. Negative 10 and 19. There's holes there. Now everything else would work in this function. Okay? But negative 10 and 19 do not work. So we would have to say, so one way of putting this would be to say all real numbers. So I could say that x is not equal negative 10 or 19. All real numbers, x is not equal negative 10 or 19. However, in advanced math, they generally opt for interval notation these days. So I'm going to describe these three intervals. Okay? This one is negative infinity up to negative 10, non-inclusive, union. Negative 10 to 19, non-inclusive, union. 19 and 19 to infinity. Okay. And that is how you would describe the domain of that function. Now for this one, that includes denominators within denominators. So, do. X minus 15 cannot equal 0. X minus 16 cannot equal 0. And x minus 17 cannot equal 0. So that includes denominators that are in numerators. Or within a complex fraction, denominators within numerators. Okay? Any denominator, you have to avoid a denominator of 0. Okay? That looks like it's probably legible, but to be on the safe side, I'm going to rewrite this one. Okay, is everything still on the screen? It is. Good. So add 15. X does not equal 15. Add 16. X does not equal 16. Add 17. X does not equal 17. So, X does not equal 15, 16, or 17. So, we'll do something similar for interval notation on these. Negative infinity up to 15, union, 15 to 16 non-inclusive, union, 16 to 17 non-inclusive, union, 17 and everything afterward. Sorry, not 17, everything after 17. Okay, so 17 to infinity. Okay, hopefully my screen stops shaking. All right. All right, and I put a number of other examples on the board as well. Okay, and I'll be doing them in a different order than what they are on the paper. Okay, I'm going to go ahead and fill this in while I'm at it. Okay, so here goes. This is actually equivalent to g of x equals 1 over x to the 4th plus 5 over x cubed plus 26. Okay, so that means x to the 4th cannot equal 0. X cubed cannot equal 0. Well, folks, the only way for a number to the 4th power to be 0 is if the 4th root is 0. So that's 0. Ditto, x cannot equal 0. Okay, that's what the long and short of this. So it's negative infinity to 0 non-inclusive and 0 to infinity. You guys can see what traditional notation would have looked like. Okay, I believe. Double check. No, it doesn't matter because at this level you shouldn't have any trouble with interval notation anyway. Okay. So here we go for the next part, f of x. So I went ahead and compared that with example 8, which would be f of x equals x to the 4th minus 2x squared plus 3x minus 14. Well, this, folks, is just a polynomial. Okay, so domain is all real numbers. This is something for you to be very careful of knowing, is that the domain is all real numbers, which in interval notation would be negative infinity to infinity. The difference between these two functions is that has a negative exponent. These are positive integer exponents, 4, 2, and 1. Okay? This is a polynomial, and the domain is all real numbers. Now, let's talk about example 7. I'm going to remind you of both of the most common domain restrictions. After I get this written over. Okay. Denominators cannot equal 0, and for square roots, the radicand must be greater than or equal to 0. So we have two things going on here. Top. The radicand, 6x plus 72, has to be greater than or equal to 0. Okay? Bottom. Well, let's go ahead and finish this one up first. So subtract the 72. 6x has to be greater than or equal to negative 72. I'm going to go ahead and remove the bottom for now. Okay? Divide off the 6. X has to be greater than or equal to negative 12. Okay? Bottom. We will be doing interval notation, but we're going to do it. We're going to save it for the end. The bottom. I'm going to go ahead and factor this. X and x. Two factors of negative 42 that up to negative 11 are negative 14 and positive 3. Okay? So x minus 14 cannot equal 0. X plus 3 cannot equal 0. Okay? Add your 14. X cannot equal 14. Subtract your 3, subtract your 3. X cannot equal negative 3. Okay? So, how to combine these two? What I'm going to do is I'm going to set 3 number lines, all vertical to each other, with all 3 critical points on them. One for the top, one for the bottom. Okay? Top. X cannot equal negative, or it must be greater than or equal to negative 12. Bottom, middle. Based on the bottom, x cannot equal negative 3 or 14. And then this one's going to be to combine the two components. All three number lines are going to have all 3 of the critical points in numeric order. Negative 12, negative 12, negative 12, vertically. Okay, they should line up vertically. I will also have negative 3. These don't need to be to scale, just make sure it's vertical. And we have 14 over here. Okay. Now, to describe x is greater than or equal to negative 12, I'm going to put a closed dot over the negative 12. I'm going to shade the numbers that are greater than negative 12. For x cannot equal negative 3 or 14, I will put open dots over these two. And I'll shade in everything else. Now what happens here is that for the third number line, I'm going to take all the critical points as given. And I'm going to shade the regions that they have in common. So there's no overlap here, but both of these are shaded. Both of these are shaded. And both of these are shaded. Okay? So now I have 1, 2, 3 regions to describe. Okay? So that's going to be closed off for the negative 12, because it's or equal to negative 3, non-inclusive. Union. Negative 3 to 14, and non-inclusive. Union. 14 to infinity, non-inclusive. Okay? Page 15. This is example, what was it? It was example 9, I believe. Okay, example 9. We're going to go ahead and deal with the same issues here. This is equivalent to x and x. I suppose I could have factored this first as well, but I won't do that. That's going to be, well, I suppose I could have done it as well here. X, negative 14, positive 3. Okay, this would be negative 16, positive 5. Okay? Let me go ahead and write that more legibly. X plus 5, x minus 16. All right, so top. Remember, for square roots, radicands have to be greater than or equal to 0. Okay? Add your 98. 7x has to be greater than or equal to 98. Divide off the 7. x has to be greater than or equal to 14. Okay? Bottom. X plus 5 cannot equal 0. X minus 16 cannot equal 0. Okay? So subtract your 5, x cannot equal negative 5. Add your 16, x cannot equal 16. All right, so I'm going to set my 3 number lines. They're going to have all 3 of the critical points in numeric order. Negative 5, negative 5, negative 5. I suppose I could leave a little bit of daylight here. 14 and 16. All right, so greater than or equal to 14 has got to be a closed dot. Okay, I went ahead and, so x is greater than or equal to 14, closed dots, shade the numbers that are greater. X cannot equal negative 5 or 16. That's going to be these two. Everything else can be shaded. All right. There's no overlap here. There's no overlap here. That's an open dot. Okay? So that's going to be that. That's going to be included. And there's overlap here. There's overlap there. Okay? Again, there's no overlap here, and that's an open dot. Okay? So the only regions we have are 14 to 16, non-inclusive of 16, and 16, non-inclusive to infinity. Okay? All right. I propose to use this one for the final example on page 15. Page 15, example 10. And I believe that function is f of x equals 8 over the square root of x minus 21. A, find domain. B, find f of 121. So domain. The square root of x minus 21 cannot equal 0. Okay? So, if we square both sides, we get x minus 21 cannot equal 0, which means x has to be greater than or equal to 21. Okay? But this this x cannot equal 21. I apologize. Okay? And also, I'm going to continue the problem over here. Okay? Also, radicans has to be greater than or equal to 0. So x minus 21 has to be greater than or equal to 0. So add your 21. X has to be greater than or equal to 21. But x cannot equal 21. We saw that before. Okay? So that leaves, if this says x has to be greater than or equal to 21, but it can't equal 21, then that means x has to be strictly greater than 21. 21 to infinity. B, f of 121 would equal 8 or the square root of 121 minus 21, which would be equal 8 over the square root of 100, which is 8 over 10, which is 4/5. Okay? And that is it for page 15. I'm going to pause here and set for the next part of the document. All right. This problem is relatively easy. You have a function here. To find f of 2, what we would do is we would go to where x equals 2, the matching y is -3. Okay? Example 6. Find f, or is the next example, which isn't on your paper. It's on your paper. If I want to find f of 6, I go to where x equals 6 and find its matching y, which is -7. Okay? Likewise, f of 4 is -5. Okay, now, this one, I got it. F of x equals x cubed plus 17x squared minus 18x plus 22. Find f of s. Okay, well, that's simple. F of s would equal s cubed plus 17s squared minus 18s plus 22. Everywhere where I see an x, I stick in an s. That's it. Okay? This one, f of z plus 7. Everywhere where I see an x, I'm going to stick in a z plus 7. Okay? Well, this is going to be z plus 7 times z plus 7. I'll go ahead and distribute this negative through. That's going to be minus 8z minus 56 minus 19. I keep that. Okay? Under the FOIL method, this is going to be z squared plus 7z plus another 7z's plus 49. Minus 8z, and these two combine into minus 75. All right. I'm going to go ahead and finish the foiling here. Z squared plus 14z plus 49. That's 49, I apologize. Minus 8z minus 75. Okay? So altogether, this is going to be z squared. 14 z's lose 8 z's is 6 z's. And then 49 take away 75 is minus 26. All right. For this one, this is going to be f of x plus h equals x plus h squared plus 23. Okay? Which is going to give me x plus h times x plus h plus 23. Okay? X squared plus hx times another x times h plus h squared plus 23. There is one simplification that can be done. These two. X squared plus hx, another hx is 2 hx's, plus h squared plus 23. Okay? This is actually an important fact. X plus h squared is equivalent to that. I'll put that on the top of the board, and we'll proceed from there after I clear the board. All right. I went ahead and put up the fact that we just went over, that x plus h squared equals that. Here's why, okay, for your convenience. Now the difference quotient is a mathematical term that stands for f of x plus h minus f of x over h. And example 1 is that. Okay, we're looking for the difference quotient of example 1, which is f of x equals x squared plus 11x squared plus 17. Okay, what you're going to want to do is you're going to want to follow the steps I gave precisely. Okay, first, f of x plus h only. Okay, you're going to do that only. So we'll start with that. Okay, so that's going to be f of x plus h equals 11 times x plus h squared plus 17. Okay, we're going to use that fact. X squared plus 2hx plus h squared, and then outside the parentheses is plus 17. I will distribute this through, and I will have 11x squared plus 22hx plus 11h squared plus 17. Second, subtract the original f of x. So minus f of x. So I'll be subtracting the original 11x squared plus 17. The original f of x. Now what you will find is that the terms of the original f of x will cancel against the counterpart. 11x squared is being subtracted from another 11x squared. So those will cancel. This 17 is being canceled from another 17. That will cancel. So the only surviving terms will be 22hx plus 11h squared. Okay? Third, the third step, according to this, which is what I follow. Third, I will do this division by h. So third, f of x plus h minus f of x over h is just this stuff over the h. And both of these h's are going to cancel. Okay, one go down a power. So that h will cancel, leaving 22x. And then 11h squared divided by h is going to be 11h. Okay? Next up, I will do page 18, where f of x equals 13x squared plus 8x minus 12. Okay? First, f of x plus h equals 13 times x plus h squared plus 8x plus h. I'm not making the best use of word space. I apologize. I'll set this up again. Okay, so this is going to be page 18, example 2, and we're looking for the difference quotient of f of x equals 13x squared plus 8x minus 12. All right, so here goes. First, f of x plus h equals 13 times x plus h squared plus 8x plus h minus 12, which will give me 13 times, this is actually that, plus, oops, I forgot the other parenthesis, plus 8x plus 8h minus 12. So I'll be scooting back a little bit with each step. That gives me 13x squared plus 26hx plus 13h squared plus 8x plus 8h minus 12. Okay? Comes from all that. Second, minus the f of x. So we're going to subtract the original f of x. So minus 13x squared plus 8x minus 12. I'm going to cancel all of these against their counterparts. Because this 8x is this 13x squared is canceled against that 13x squared. That 8x is subtracted from that 8x. And this minus 12 is subtracted from another minus 12. Okay? So the only survivors are the terms which have h's in them. 26hx plus 13h squared plus 8h. Okay, I'm going to reorient the arrows. Actually, let me just go ahead and do all that again. Okay, so this is going to be 26hx plus 13h squared plus 8h. Third, f of x plus h minus f of x over h is 26hx plus 13h squared plus 8h over h. Okay, and those h's are going to cancel against counterparts. So that would be 26x plus 13h plus 8. Okay, because the h's will cancel there. Go down, cancel, go down a power, cancel. All right, I'm going to clear the board. And we'll do the next part. Okay, we are now on page 19, and the end is finally near. What we're going to do here is we're going to find something called a derivative. Okay, now you may notice the difference quotient expression again, but there's a limit, and it says that h approaches 0. Now, what that means is not appropriate. It is not important at this point. Essentially, it means what this would equal as h gets closer and closer to 0. But again, that's not very important to the purposes of this problem. Here's what you would do. The same steps as we did before. Find f of x plus h. After being finished with that, subtract the original f of x, and you'll be canceling with the canceling terms. Then you'll do the division we just did. Now here's what's last. You will let h equal 0 after you have done these three steps. After you have done these three steps, you will let h equal 0, plug in, and then simplify. Here goes. Okay? Now, again, well, you guys are probably thinking h can't equal 0. That would make this undefined. The value is undefined. The limit is not. Okay? So if that's, don't worry too much about the details. Just follow the steps. You will get a fuller explanation in a calculus class. So here goes of what limits are. But but algebra students, advanced algebra students should be able to do these steps. Okay, so here goes. First, f of x plus h equals 14 times x plus h squared minus 37. Okay? I just plugged x plus h in for x. All right. So that's going to be 14 times x plus h squared is x squared plus 2hx plus h squared. And then minus 37. Okay? Distribute. and we have 14x squared plus 28hx plus 14h squared minus 37. Okay? Second, minus the f of x. So we have finished the first step. Now we'll do the other step, which is to subtract the original f of x. Okay? And again, these are going to cancel against counterparts. 14x squared is canceled against 14, is subtracted from 14x squared. That's going to cancel. Minus 37, minus another minus 37. Canceling, subtracting something from itself, these will cancel. So my surviving terms will be these two. 28hx plus 14h squared. Okay? Next up. Third, f of x plus h minus f of x over h is 28hx plus 14h squared over h, which gives you 28x plus 14h, because this will go down a power and that h will cancel entirely. Last, and not before, last, h equals 0. So I will have 28x plus 14 times 0. Okay? Which gives me 28x plus 0. The derivative is 28x. That is your derivative. All right. So page 20. Page 20 talks about an object that would be thrown on Mars. Its height in feet after x seconds. So it's being thrown out from 21 feet high at 44 feet per second. That's what the document says. Now, on Mars, this is about negative 6.1. On Earth, it'd be negative 16. On Earth, it'd be negative 16, but on Mars, the gravity is weaker, so it's negative 6.1. The question asks the rate of change in height at x equals 4 seconds. So the first thing we're going to do is we need to find the derivative first. So do derivative. Because the derivative gives the formula for rate of change. So first, f of x plus h equals negative 6.1 times x plus h squared plus 44x plus h plus 21. Okay? I'm going to pull this back a little bit to make sure there's plenty of room. So that's going to be negative 6.1. I am going to use a shortcut for this problem. Okay? X squared plus 2hx plus h squared plus 44x plus 44h plus 21. Okay? So that gives me negative 6.1 x squared minus 12.2 hx minus 6.1 h squared plus 44x plus 44h plus 21. Having finished f of x plus h, now I will subtract the original f of x. So I will be subtracting negative 6.1 x squared plus 44x plus 21. I'm going to cancel the 20. This 21 is subtracted from that 21. That 44x is subtracted from that 44x. And this negative 6.1x squared is canceled against that negative 6.1x squared. So the only thing left is negative 12.2hx minus 6.1h squared plus 44h. Third, this step, negative 12.2hx minus 6.1h squared plus 44h over h. All three terms are divisible by h, so I do it. That gives me, here the h's cancel, negative 12.2 just x minus h squared divided by h will just leave me h to the first. And here the h's cancel. Okay. Fourth step. So here's the first step. Here was the second step. Here was the third step. This is going to be the fourth step. Fourth, h equals 0. So I'll have negative 12.2 x minus 6.1. H will be replaced by 0 plus 44. And that's 0. Negative 12.2x plus 0. Sorry, I'll do minus 0. Plus 44. The derivative, f prime of x, is negative 12.2x plus 44. Okay? That's the symbol for the derivative, f with an apostrophe. Okay? And I'm going to finish the job up here. Finish. Rate of change is f prime of x equals negative 12.2x plus 44. At x equals 4 seconds, that's going to be negative 12.2 times 4 plus 44. So that's going to be negative 48.8 plus 44, which is negative 4.8. Application. That's going to be negative 48.8 plus 44. Which gives me negative 4.8. So what that means is that's negative 4.8 feet per second. How did I get that? Heights measured in feet and the time measurements per x seconds. Okay? So that means it is falling at 4.8 feet per second. So it's just now starting to fall. On Mars, on Earth, it would have already hit the ground. On Mars, it just reached its apex just a fraction of a second ago, and it's just now beginning to fall. Okay? All right. Push that back a little bit so you can see the big picture. I'll reword all this again. Okay, I'll do that again. The derivative, the formula for the rate of change is that. We found it the long way, doing the long way, or with long work. And then 4 seconds, I plugged in 4. So that was negative 48.8 plus 44, which is negative 4.8. So that's negative 4.8 feet per second. Okay, feet per second. That means it's false 4.8 feet per second. Okay? On Earth, again, on Earth it would have already hit the ground. But on Mars, it just now began to fall. That's not a very high rate of speed. Okay, I'm done.